This problem demonstrates the Archimedes principle, which is that if you take an object, like this cylindrical thing over here, and you dunk it in a tank of water, the water will rise because the object is displacing the water. It's pushing the water out of the way as it sinks into the tank. The water has to go somewhere, so it rises, and you have a height increase of the water level. So to figure out what the water level rise is going to be, we're going to have to figure out what is the volume of this object. So first of all, you have to know the volume of a cylindrical object. It's going to equal not 1/2. It's going to equal pi r squared. Okay, that's the area of this circle right here. And it's going to be that times the length of the object. So let's put in some things here. I know, well, I can just say pi is pi. And I know that the radius based on this picture is 4.5 centimeters squared. And the length based on the picture is 12 centimeters. So if I plug that into my calculator and I say pi times 4.5 squared times 12, I get a volume of 763.407. Now the units aren't terribly important, but if you want the units, they are cubic centimeters. That's the volume of this cylindrical object. Now when it gets dunked in this tank over here, and now it's sitting inside the tank, right? That's going to make the water level increase. And the amount of that water level increase is given by the volume of the object. So we just have to figure out if the water level goes up by this little amount that I drew in the arrow, what height is that going to be? Well, you figure out the volume of the water in the tank. Let's call this height x. Just put a value on it, x. The volume of this shaded region, I'm going to shade this in red. The volume of this shaded region of water must be equal to 763. Okay, so we start with that, 763.407. Now, it's equal to 19 centimeters times 25 centimeters. Okay, that's the base dimensions of the tank, 19 times 25, times the height that the water went up by. So look at this, we've got an equation here, and all we have to do is divide both sides of this by 19 and by 25, and we are going to figure out the height that the water in the tank rises by. So 763 divided by 19 divided by 25. Okay, x, the rise of the water level, is 1.607 centimeters. So it goes up a little bit, not too much. And that's not too surprising. I mean, it's a pretty big tank. So this will work anytime you're putting an object into a tank. I think the only restriction would be if the object doesn't fit. Otherwise, you're good to go.